Yeah, cool. So first you should download Visual Studio Code. The link is pasted in the chat box, and you can find the resources for this workshop also. So first I'll tell like how you can download the code. Just open, first you have to download um, Notes app Node.js, the first link, and then just go to code and download as zip. So in this workshop, we are going to learn about Node.js. So like this won't be from scratch to complete Node.js. You'll get an idea of what backend development is and what you need to learn. And I'll provide some additional resources so that you can know more about Node.js and backend development. And then we'll do a demo code application, Nodes application. So first we'll write the application in Node.js, and then we'll move to Express.js and see how Express.js is very simple compared to Node.js. So this is the agenda for today. First, we'll discuss about the JavaScript before the invention of Node.js, and then I'll introduce you to Node.js, and then we'll start backend development with Node.js and some of the important modules in Node.js. And I'll demo the application or Nodes application. So first demo is going to be just a code walkthrough, and the next demo, which is going to be Express.js, that's going to be the actual backend which we develop for APIs or web services, and that is going to be the hands-on. And then I'm going to show how we can connect front end and back end using different methods. And I'll provide you some additional resources so that you can learn more about Node.js and backend development. So before Node.js was invented, JavaScript is only meant for developing front-end applications. So you can use JavaScript and interact with the web pages. For suppose in a web page you have a menu bar. So if it's a drop-down menu, when you click on the menu, you'll see list of options, right? So when you click on that menu, it will show a list of options. That interaction is written in JavaScript. So up until now, JavaScript is only meant for front-end development. And in order to develop any back-end applications, like developers use Java, C Sharp, and PHP and Ruby. So those are the most used languages before Node.js. And like Java and C Sharp, those languages use threads to handle each request. So if you see in this diagram, these clients are users. So client can be anything. We can access a website through mobile or desktop. So these are clients, and each web application is hosted in a different server, a web server. So these servers are also computers, but they are in a different remote locations. So we access them through internet. And so whenever a client makes a request, and the web server creates a thread for them. So this thread is a lightweight process, you could say. And for each request, there's going to be one thread. And if there are multiple requests, web server will create multiple threads. So this thread is responsible for any backend service like reading or writing to a files or getting data from database. So in this diagram, we can see just 4 clients. So imagine if there are like 1,000 to 2,000 or million clients accessing a web application. So in that case, there are so many threads. And the disadvantage of using Java, C Sharp, or PHP, those languages is if there are multiple users, then there are going to be multiple threads. So web server should maintain all the threads. That's a big disadvantage, because it needs to keep track of all the threads and which requests they are processing and the client details, everything. And for example, let's suppose we are getting data of some product from a database. And if the data retrieving the data takes like 2 to 3 minutes, then the thread is supposed to wait until we get the data, right? So it's like if there are million threads and each thread has to wait for 2 to 3 minutes, and that's just waste of time. And we need to keep track of these threads and resources. And even if the threads are idle, we are allocating the resources for them. So the resources are wasted here. So this is another disadvantage of these languages, and there are no concurrency. So the threads are being idle here. So instead of being idle, it could process other requests, right? So here we could use Node.js and implement concurrency there. And resource utilization, as I said, even if the threads are idle, we are still allocating resources for them. So it's many resources are getting wasted. So this is the disadvantage of using Java, C Sharp, PHP, or Ruby. So uh, Node.js, every JavaScript application runs on a browser. So even if we are running a program on a browser, we need a compiler to execute the program, convert it into a language that machine can understand. So every browser has a JavaScript engine in it. So Chrome also has a special engine called V8 engine. So the developers, what they did is they took this V8 engine and they wrote a C++ program and wrote entire wrapped the engine in the C++ program. So this is called as Node.js. So the C++ program has many libraries which can be used to make network connections and file reading or writing operations, or parsing the URLs. So there are many external inbuilt modules in that C++ program. So this entire thing provides us a runtime environment for running the JavaScript applications outside of the browsers. So this gave us the opportunity to use JavaScript for backend development also. So unlike the backend languages like Java, C Sharp, which we discussed in previous slides, Node.js is asynchronous in the sense it only has one thread. If you see in the diagram in the web server, there's only one main thread, and whenever a client requests for any page or any resource in our website, the request is going to be handled with the main thread. So this main thread is going to read data, and there's something called callback functions. So it's like main thread will suppose client one is asking for a file from the server. So the request goes to the main thread first, and then the main thread will read the data from the file. And until the reading is completed, it will handle the second client's request. So similarly, once the first client request is done, like reading the file is completed, the process will ping the main thread that, okay, I read the file. So now you can proceed with sending the response to the user. So at that time, it will send response back to the client. So similarly, if there are multiple requests and if reading file takes like 2 to 3 minutes, then the thread will not wait until it reads the file. It starts processing the second client's request. So this is the biggest advantage of Node.js. So it won't wait until process is completed. It goes to the next request and performs the next completes the next request. So what happens? Like oh, the first request will wait. Suppose now the client requested here. The client one requested for a file from the server, right? So it will read the data first. The request will get to the main thread. So the main thread is going to allocate a different process. So that process will read the file. And while it's reading the file, the main thread will handle another request. So once the file reading is completed, the process is there, right, which is reading the file, that will ping the main thread that I read the file. So the response is ready. You can send back to the client. So then the main thread will send the response back to the client. It won't cost because anyway, if we use Java or JavaScript, the amount of time taking to read the file is same. So while reading the file, if there are multiple threads, instead of waiting for the file reading to complete, we could process another request. Suppose like the second request is just asking for a static page. That could take like 2 to 3 milliseconds. So it could process that request first, right? So the smallest request will be processed. Meanwhile, the reading the file will be in place. Like that. So this is called concurrent execution. So the advantages of this is we don't have multiple threads here. So the server is not responsible for like creating multiple threads per request and maintaining them and creating resources. So suppose if for small applications the requests are going to be less, at that point it's easy to maintain the threads. Suppose if there are a million requests, if you take big sites like Amazon or Twitter, there are going to be so many requests. So it is supposed to maintain all the requests and create multiple threads and keep track of all the threads. So allocating these threads also takes a lot of time, and you need some resources to allocate the threads. So that is called thread overweight. In this case, with Node.js, we only have one thread and we need to maintain that thread. So it's fast, and then it can process multiple requests at one time. So the request which is going to take long time will process the request, and then the thread will meanwhile process another request which is smaller, like that. And the performance is going to be high because the thread is not waiting, web service is not waiting. It's constantly performing multiple requests at the same time. And because multiple threads are not there, the resource utilization is also low. It's only the web server has to maintain only one thread, and we can use the same language. JavaScript is already used for front-end languages, right? So with the help of Node.js, we can use the same language for backend. So if like developer knows one language, it's sufficient to build a proper full stack application. That's one of the biggest advantages with Node.js. So for every HTTP, so there's something called HTTP protocol. So there's something called HTTP protocol. So that HTTP protocol has like list of things like IP address of the user and the request he wants. Like suppose I'm requesting for like normal static page. So if I go to Amazon.com, there's first going to be a home page, right? So that page when I go to Amazon.com, it's going to send me that request. So the request has I need to get the details of Amazon.com. The request has the details, and the response is going to be what server generates for us. So for each HTTP request, that HTTP data is going to be stored in the server. So once the process is completed, we'll send back the servers to the same user. Yeah. So once you see the code, you'll understand like how each request and response are going to be processed. So if anyone has any doubts. So Java we use gate mapping, post mapping. Yeah. Even in Node.js, you use this get, post, and delete. These mappings are like protocols. These are like common standard everywhere. So if you want to get the data, you should use get. Suppose if you're submitting a form, like a login form. So this login form, when you fill the form and submit the form, this data is going to be sent to the server using post request, because get requests are something you can see in the browser URL. So all the request parameters will be visible in URL. Suppose you are logging into a website. If it uses a get request, then entire username and password is visible in the URL. That is something we should avoid, right? So that's why we use something called post request. So same as Java. So these are some important modules in which are provided by Node.js, and this HTTP module is the main module. HTTP module is the main module that we can use to create the HTTP servers. So we can create HTTP server, and that server will handle request and response, each client request. And FS is for reading and writing to files. This handles the file operations. And OS module is for accessing the operating system resources. And there's something called query string. So whenever you perform a get or post request, we are going to send some data to server. So we need to read the data, process the data, right? So the data is going to be in different formats every time. It's not going to be the same. So we can use this library and we can process the request, get the data in similar form every time. And URL. URL module has everything about URL, like which URL the user is trying to access and IP address of the URL users, everything like that. And event module is like there are certain events in Java, Node.js. So whenever that event is triggered, we can run a function. Suppose we get the data from user to the server, right? So we can have there's something called on data, this event. So each time the data is received to the backend in chunks. So we are supposed to gather entire client data and then process the request, right? Suppose if you are logging into a form, so what Node.js does is it retrieves the data from the client in chunks. So one time we'll get the user ID and one time you'll get the password. So before processing the request, we have to wait until we get entire data, right? So on data event will loading the data to the server, and there's something called on end. So once the client request is completely reached the server, that event will trigger. So then we can run a separate function. At that point, we can process the request because when the end event emits, we know that the entire data is with us. So that you will see in the code demo. And V8 is another module which contains the information about the runtime environment. Like I told, right, Chrome has a V8 engine. So this module will help us to get all the information from the runtime environment. And like that, there are many modules in Node.js. So some of the important modules to like create a web applications are HTTP and file reading and query string URL. These four modules are very important to create the web servers. So installing Node.js is very simple. You just have to go to this site Node.js, or you can directly search for. So you'll be able to download based on your operating system. I hope everyone download the Node.js. So if you didn't download, you can download while completing this presentation. And npm is called Node Package Manager. So when you are developing an application, you will be dependent on many libraries, right? So these libraries are sometimes external. If it's inbuilt with Node.js, once you install Node.js, you'll have access to all the code. You can directly import the code and start using them. If it's external, you're supposed to install the dependencies, right? So Node Package Manager, NPM is something that comes with Node.js. So it helps us manage all the packages. So without the NPM manager, you have to download the dependency manually and include it in your code and import. So with NPM, you can just write commands like NPM install the dependency name. So it will install the dependency for you. And whenever you are giving the a code to any other developers, they don't have to see through like which dependencies it's using. They don't have to go through the dependencies and install one after them manually. There's something called package.json. For every node project, there's something called package.json. I'll show you a sample of this. So this one has entire dependencies which are required to run the application. So if you see here, it has a node mount dependency. And suppose if it's an Express.js application, then there will be Express.js dependency. So once you open the project and click on npm install, it's going to install all the dependencies for you from the net npm repository, and you will be able to run the application. So you can find all the repositories in this site. I'll show you just a sample site. So here, this is the npm side. You can find any dependency here. Suppose React.js is a front-end library. So you can search for React.js. Yeah, same as Maven. So this is it. So every React npm downloadable dependency has instructions. You can see how you can install it and how you can use it and documentation and everything. So this is a HTTP module. So HTTP module is something that is responsible for creating the server. So in order to run a web application, you need to have a server. It needs to be associated with some IP address. So then only you will be able to access the application anywhere from the internet. So this HTTP module has all the methods and all the functionalities that are required to create a HTTP server. So and it provides all. It can be used to create RESTful APIs, web applications, and any web services. And it has many features. As I said, the data which is going to be received to Node.js servers is uh, asynchronous. So the data is going to be received in chunks. So we need to process these chunks one after another. So we need events for that. And these events are also included in the HTTP module itself. And we can, other than HTTP, you can use any third-party libraries to create the web servers. And one of famous one is Express.js. That Express.js is very popular for creating REST APIs. And this is creating a web server is very easy with HTTP module. So if you see here, uh, first you have to require HTTP. We are just storing it in a HTTP variable, and then require is like importing the HTTP module into the code. So in order to create the server, first you need to import everything which is used for creating the servers. So if you see here, we need a host name. As I said, for every web server, web application, we need to have a proper host name so that it will be accessible from anywhere from the internet. And each application will run in a different port. For example, FTP servers will run on a different port, and HTTP protocols runs on a different port. So, and HTTP.create server is going to create a HTTP server for us. And there are two parameters for each request. One is request and another one is response. Request contains entire data like what user wants and where the request is originated from. So the request contains IP address of the user and the data that user wants. And if suppose if it's a form or anything, the user should send the form data to the server, right? So the data is also included in the request object. So response object is something server is going to send back to the user. Once we process the request, we are supposed to send back the data to the users, right? So that part is stored in the response object. So response dot status code is every request is associated with some status code. So 200 is success status code. Suppose whenever sometimes you try to access a web page and you see an error like 404 not found, right? So that is a HTTP status code. That means the page is not available in the server, and this status code we are supposed to set the status codes appropriately, like based on the business logic. Suppose if we have a bunch of pages in our website and user is trying to access a page other than the available pages, then we have to handle that request. We are supposed to, suppose if user access a page which is not available, we should handle it and send back a response like this page is not available, and with the 404 error. So the browser displays the result accordingly. And the set header is like for every response, you need to specify the type of content. Sometimes you'll pass JSON data back to the user. Sometimes you're going to pass the HTML data. So this content type is going to be what type of content the server is returning back to the user. And response.end is once you write this response.end, the entire content which is written in end function is going to be returned to the user. So this is the server part. And once you create the HTTP server, you need to start the server on some port. So the server.listen is going to open the port and start running the application on that port. So then you can access the server using HTTP localhost colon the port. Then you will be able to access the application. This has other modules in other module called query string, which is required to get the data from the query string from each request. So same as the HTTP, for every module you are using in Node.js, you're supposed to import it first. So if you see here, we are using require and then query string. So the require is function which will import the data, import the code into the file, and within that function is going to be the library name which you want. And if you see here, this is a query string. So every query string will look like this. Name equal to John. So the first value before equal to is the name of the variable. So variable equal to the value. So now server can get this value using query string dot query dot name. So that will return John. So if we are submitting a form, we need to get username and password, right? In that case, a username equal to username and then and at the rate symbol and password equal to password of the user. So this is a sample query string. And then we imported the query string, right? So query string dot parse this QS. We are passing the query string. So once we pass the data, it's going to be generated as a JavaScript object. So I'm just console logging this. And if you see the output, you can see the object type. So it's in now JavaScript object type. So now you can access this JavaScript object. If you want the name of the user, you can just say pass dot name. It will print the name. And if you want age, pass dot age. It will print 30. So with this query string, you can access the data which is sent to the server. Similarly, we can take a JavaScript object and convert it back to a query string, which is shown in the below example. Similarly, you have to import the query string and then you can see the JavaScript object here, name and then John, and the next value is age, and next is city. So we can use query string dot stringify. This will convert the JavaScript object into a string. So if you see the output here, it's name equal to John and age equal to 30. This is same as the above example. So we can use username and password. It depends upon the request type. If it's GET request, we are never supposed to. Yeah. Suppose we are using username and password. Where we are doing validation? That validation should be done in front end. And sometimes, even if you do the validation in front end, users can, like hackers can intercept the data and they can modify the data on the go. So we are supposed to do validations in the front end and in the back end. So both the parts. So if you want to do validations, first you'll parse the data And once you pass the data, you can see the JavaScript object. So now you can write some conditions like if name contains any characters other than alphabets, then return some error back to the user. Or if age is greater than something like that, you can write the conditions. So first, I'll show you the demo of the application we are going to build. So entire code is in GitHub, so you can download this as a zip file. So I already downloaded the code. I'll just open it. This is a sample application. First, I'll run the application and show you the demo of it, what we're going to build. So as I said, before running any node application, we are supposed to install all the dependencies. So if you see in the package.json, we need a dependency called node1 to run the application. And before running the application, we should run a command called npm install. So if I run this command, it's going to install all the dependencies which are required to run this application. So it says 32 packages are added. So once you run npm install, you can see a new folder called node modules. So this one contains all the dependencies which are required to run the application. So once you install all the dependencies, you can run a command called npm start. So this will start the server and you can access it. So as soon as I run that command, you can see that server is running on port 3000. So this server, you can modify it here. Like you can decide which port you want to run on. So I specified 3000 port. So the server is running on 3000 port. Now, in order to access the application, I need to open localhost 3000. So this will show me the application. So this is the application we are going to build. And I have already written the HTML code, so you don't have to worry about it. And the styling, everything, we don't have to make anything. So only thing we are supposed to do is write the backend code. So even for this Node.js application, I already wrote the code. So I'll just explain you how Node.js, how we will create the server in Node.js and how difficult it is to create a server in Node.js. Then we'll move on to Express.js. So writing the servers in Express.js is very simple compared to Node.js. So this is the application. So we can add nodes in the application. So we can decide if the nodes is important or not. If we select important, then the nodes is going to be in red color. If you don't select it, it's going to be in blue color via black color, and you can just delete the nodes. So we need to write logic for these operations. So first I'll show you the HTML code. So if you see here, it's basic HTML code. In the UI UL list tag, I'm just writing a placeholder text. So here we are supposed to populate the list, all the nodes. So I just wrote a placeholder text here. So what we are going to do is we will read the entire HTML file in the server.js, which is Node.js. and then we'll generate the list element tags. So if you see here, these are the nodes. I wrote a array. So each array has a JavaScript object. So each object has an ID content. That's the content is the text which are displaying in the list, and then important, whether it's important or not. So I initially I populated 5 nodes here. So whenever I start the server, the 5 lists are populated automatically in the application. So what we are going to do is we are going to iterate over all the lists, all the nodes in the list, and then generate a HTML content in the Node.js and replace the content with this temporary string. Yeah. Have to define the JS file. JavaScript is a JavaScript file in HTML is going to be something you use to perform any interactions. Yeah. So it depends upon the use case. Like if you have any interactions that require JavaScript, then you can include the JavaScript in the script tag or a JS file. Because it's not required here, we just need the backend code. So this is a HTTP. As I shown you in the example, I'm creating a HTTP server. Yeah, this part is written here. I'll explain in a minute. So HTTP create server is going to create the HTTP server. And as I said, for each request, we'll have a request and response object. So, and here in this line, I'm just getting the path name. So URL pass is going to take the entire URL. So this is the, if this is the URL, it's going to get the entire URL in the response. So if it has like, so this entire thing will be stored in the request.url. So now we need to check which endpoint user is trying to access. First, we have to check what is the request method, whether it's a get method or a post method, because we also have a form, right? So whenever we are adding a node, so whenever I click on the submit, it's going to be a post request. So if you see in the HTML, the action is post, the action is add node, and the method is post. So this is going to make a post call to the server. So first we have to check the type of request, and then based on the path name, we are supposed to write different logic. So in the get request, we have two endpoints here. One is slash endpoint, which is this one, localhost 3000 slash. As soon as user enters this request, we are supposed to display the nodes and list of available nodes and the styling for it, right? So we are basically supposed to display the entire HTML for this. So in the slash, what we're doing is we are the HTML page is stored in public slash HTML index.html. So fs.read file is going to read the file. It has two parameters. So it has, this is the syntax for the reading a file using Node.js. So the first parameter is the location of the file. Here it is stored in public and then index.html. So this is the location of the HTML file, and callback function is something, as I told you, everything is asynchronous in Node.js. So we need to provide after reading the file is completed, Node.js will run this function, this callback function. So as soon as it reads the index.html file, this method will run. So suppose while reading the file, if there are any errors, we are supposed to handle them, right? So the callback function has two parameters. One is error and another one is data. Suppose if there is any error while reading the data, so in that case, the error parameter will be populated. So we are checking if there are any errors. If there is no error, the error parameter is going to be null. So first we are checking if error parameter is null or not. So if it is null, then it means that there is no error. If it's not equal to null, it means there is some error. So if it is not equal to null, then this part will run. So we're just writing 404, which means page not found, and we are returning the response to the user. If this is equal to null, it means there is no error and the reading the data part is completed. So the data is stored in the second parameter. So now, as I shown you in the example, for every response, we are supposed to set a proper content type. In this case, as soon as user opens the website, we are sending him the HTML. So the content type is text/HTML. So now, as I said, we are supposed to uh, read the entire HTML file and then replace the nodes list with the nodes we have in the server. So I just declared a variable called nodes list, and then I'm iterating over the list of nodes here. So I'm iterating over the nodes. So here we have 5 nodes. So as soon as user opens the page, we'll display the 5 nodes. So I'm iterating over the nodes, I equal to 0, and nodes.length is the length of the array. And then I plus plus, just incrementing. And then I'm taking each nodes. So nodes of I is going to be the ith node and storing it there. And I'm creating a list tag. So this code will create a list tag. I'll just console log it and show you the example. So if you see here we are generating a bunch of HTML tags. So list HTML, and we are adding a delete note here. And then what we are doing is we are iterating over the entire array and generating n number of list HTML tags. And then once we generate all the list, so we already have this placeholder text in HTML file, right? And we generated a file list elements using the loop here. So we are just replacing it with the HTML tags. So as soon as I do data.toString, it's going to convert the HTML data into a string, and then replace is going to replace the nodes list, this temporary placeholder, with the HTML dynamic HTML data that we just generated. So this entire thing is going to be placed in this part. So then you will be able to see all the nodes. So if I inspect the code here, and as you can see, first we have the main container, and then in this we have a UL, unordered list. So if you see in the HTML, the unordered list is empty. We just have flower braces and nodes list, just a placeholder text. But if you see in the server, you can see there are 5 list tags, right? These list tags are generated from the array we have in the server. So we are writing a list tag and then the content of the list, and then we are writing a hyperlink, with the delete location. So as soon as I click on this, the request is going to forward it to delete node ID equal to 1. That means server will process that request. We're also passing the ID here. So it will use the ID and delete the appropriate node. So this is the logic for displaying the HTML file. This is one endpoint. And the second endpoint is deleting the node. As soon as I click on the node, delete hyperlink, we are deleting the node. So I'll just show you how the request is going to be. So here we are getting the path name. So I'm just printing the request URL and the path name. So if you see here, the path name is slash. It means it is reaching the first because we don't have anything here. So if we make a different request, suppose if we are trying to add, because the action of this HTML form is slash add node, right? So if I type anything, if you see in the console, we are calling this slash add node. Then we are going to run this block of code because it's post request. We are going to run the else if condition because the path name is slash add node. This condition is going to be true. Then we are going to run this code. So like that, we are parsing the URL and checking the path name, which path the user is trying to access, and run that code. So this is the logic for the delete node. So if you see here, same as the previous one, we are passing the URL and then we are getting the ID of the node. Because for every delete, if you see in the HTML, so if you see the hyperlink here, we have slash delete node and question mark ID equal to 2. As I said, everything after question mark is going to be a request parameter. So we are fetching the ID from the URL and then deleting the node. So if I console log here, so if I click on the delete, we know this is the first node and the ID is 1. So if I click on delete and here we'll see 1 because we are printing the node ID. So we are just passing the URL and getting the ID of the node. And now we are storing every node in the list, right? So we are filtering the node. So nodes.array.filter is going to run this method. And in this method, we are just removing the node which has the same ID we passed in the URL. So previously I clicked 1, right? So the node ID is going to be 1. It's going to iterate over entire nodes. And if the node ID is equal to the ID we passed, then it's going to delete it from the array. And then once we are deleting it from the array, we are again sending the response to the user. So in that response, we are redirecting it. So because once we delete the node, we are supposed to reflect that back in the UI also, right? So we are redirecting the request to slash. So slash is going to execute this part of the code, right? So again, we are reading the entire HTML file and then creating the list based on the new array data, because one node is deleted from the array. So now there are only 4 nodes. So it is going to iterate over the array, and this time it's going to generate only 4 li elements. So this is for deleting, and same for the post. For adding, the request is going to be post. So here, same as the previous logics, we are checking the path name. If it's post and the path name is add node, we are executing this block. So as I said previously, the data from front end is going to be received by the backend in chunks. So entire data is not going to be received by the backend in one stretch. So we have a event called data, as I said. So request dot on and data. So this is going to run this block of code. So this code keeps running until we get the complete data from the user, from the client. So we just took a request, we declared a variable and then appending the data. So the chunk is going to be the data which is sent from the user to the server. So we're just appending the data each time to the request body. And once the data reading the, if once the client sending, once clients completely send the data to the server, it's going to emit a new event called end. So this time we are going to read this code. This method will be run. So this method has logic for passing the query string again. So this time we are using a query string, and we are using query string and parsing the request body, because in the get parameter, in the get request, we are using url.parse because the query is going to be stored in the URL for the get parameter, get request. So for the post request, it is stored in the body, right? It's not visible in the URL. So we are using query string to parse the request body, and the request body contains the data of the form. So here, once we parse it, here we are just getting the ID of the last node from the array list. So first we are checking if the length of the nodes array is 0. If it is 0, there are no items in the array. So if it is true, then the length last ID is going to be 0. And if it is false, it means that there are some nodes in the array. So now nodes of array.length, we are just taking the length of the node and getting the ID of the last node. And we are creating a new node here. So this parsed body.content is the data which we got from the user. So if you see in the HTML file, the name, each input tag has a name. So we will use this name to access the data in the backend, right? So here the name is important, and the name for the content is content. So we are using parsed. Once we parse it, parsed body.content is going to be the content which user entered. And this is going to be the data of the checkbox. So if it is on, we are storing it as true, else we are storing it as false. And we are just appending, incrementing the ID and then storing it and pushing the node to the array list array. So once you nodes.push is going to append the new node to the array. So again, we are sending the response, redirect response to the slash URL. So as soon as you add something to the application, the entire code is going to be processed. And once addition of the new node is completed, it will send a redirect request to this URL. So this URL is what the UI we are rendering, right? So again, it's going to iterate over the nodes, and it's going to show all the list of items we have in the backend. So as you can see, the code is very complex here. There are 3 reasons for that. First, we are creating one server, and inside we have 3 if-else conditions. We are checking if it is a get post or get post request or get request. And again, within the post request, we are checking the path of the URL. and processing it based on the path. So we have again 3 nested conditions. Suppose this is a small application, right? Suppose if there's a big application, and obviously the endpoints are going to be more, and the amount of nested code is going to be more, and there's going to be more if else conditions and like that. So the code becomes very messy and it's hard to maintain. It is because uh, the backend and the front end code is included here in the server itself. So if there is any error, if you want to debug anything, it's hard to debug because we are writing the HTML in Node.js itself. So what if the front end and back end is completely different? So it's easier, right? That way. So Express.js is going to help us with that. So this part I already load because it's complex and it takes a lot of time and it's hard to debug. This is standard for every application. Yeah, this is a normal way people write backend applications, like I mean web applications using Node.js. So without using any third-party libraries. So if you use third-party libraries like Express.js, you can create the backend separately and then front end separately. So with that, you can easily have a different applications, front end and back end, and you can test them individually. Suppose if you're maintaining back end and front end separately, uh, if there are multiple developers, one developer can work on back end and another can work on front end. So the amount of time is saved is going to be more. And if you see the Express.js code, you'll as soon as you see the code, you will understand how difficult it is and how easy the Express.js is. So as I mentioned, these are the benefits of using Express.js. Um, we can create the node backend servers very easily with Express.js. And as I said, there are no need of any if-else conditions, many if-else conditions, and code is modular and easy to test. And we can write easily. And Express.js is also built on top of HTTP core module. So there is no impact on performance there. So this is the sample example of Express.js. This is a small example. As soon as you see the example, you will understand how easy it is. So in the Node.js, what we are writing if conditions to check the request, get or post request. Again, we have a bunch of if conditions to check the path of the URL. So if you see in this example here, there are no if else conditions. So it's just app is the Express app. We are just importing them, and then app dot get is for get request, and post is for post request. And then in the first parameter, we are just specifying the URL endpoint, and then request object and the response object. So as you can see, if I want to write the same logic in Node.js, I need to have a first condition to check if it's a get request or post request. And then I need to have multiple if else conditions inside the get or post based on the requirement or use case. So again, we'll rewrite the entire application, Node.js application in React. I mean in Express.js. So that part is there in Nodes app API. You can download that from the GitHub. So you can just open and download it as a zip. So in this also we have same number of nodes. So entire application is going to be same. And one thing about Node.js, Express.js is you can write the endpoints and you can test the endpoints using an application called Postman. So we'll start writing the code here. So first we are importing the required packages. So we are using Express.js. So we need Express.js to run the application and require Express.js. We are installing them. And then body parser is previously in Node.js, we are trying to use query string and URL to pass the request from the user, and we are getting the data using that. So body parser is a different library which automatically does it for you. So as soon as you get the request, it will automatically convert the data into JSON format, which is JavaScript object. So you don't have to convert them. So the amount of code is going to be very less. And we are using Express here. We are just initializing the object. And then CORS is, suppose you have front end and back end in the same computer, and the IP address is going to be same. So there's something called cross origin policy. So you can't establish a communication between two applications in the same server. So in order to run this application, you need to use CORS library. So with you just have to impose CORS, and app.use is, if you use app.use is like it is going to use the library or dependency before running the application. We need to use CORS to access the established connection between front end and back end. So we are using this library here, and similarly use body parser.json. So body parser has many data formats. So one of them is JSON. So body parser.json is going to convert every request we get to backend into JSON type. So the reason we are using CORS, as I said, because we are running the application front end and back end application in the same laptop, I mean same IP address. So in general, when we deploy applications in real time, the front end is going to be deployed in separate server and back end is going to be deployed in separate server. So there won't be any issue, and we don't require this dependency at that point of time. So if you see the first endpoint, the format, the syntax for any Express endpoint is app, which is the object we created using Express, app dot. If it's get method, we are going to use get. If it's post, we are going to use post. So I'll just say method. And in this, first we are going to specify the endpoint. And then we are going to have a callback function with request and response object. So once we receive the entire data, previously what we are doing in Node.js, if we have a post request, we are using event handlers like on data and on emit and reading the entire data manually. So what Express.js does for is it calls this endpoint only when it receives the complete request. So we don't have to use any event handlers there. So once we get entire data, it will call this endpoint, this callback function. This function will be run. So in the get endpoints, what we are supposed to do, we are just going to return the list of all nodes available in the server, right? So this is going to be just response.json. So response.json is going to convert the nodes array into JSON type, and then it's going to return it back to the client. First, we'll run this application. and see if the get endpoint is working or not. So as I said, before running any application, if you see on the left side in the project explorer, we're not able to see node modules folder, right? So there are no dependencies installed at this point. So before running the application, we are supposed to install all the dependencies. So if you do npm install, it will install all the dependencies required to run the application. So as soon as I run this command, you can see it generated a node modules folder here. So it has all the dependencies. So for this application, we are using body parser, cors, express, and nodebound. So as soon as I run that command, all these 4 libraries will be installed in our application. And if we should, in order to run, we are using npm start. So now the server is running. Before that, we are supposed to we are supposed to write code to so that the server will listen to the request. So right now there is no code for listening to the request. So we are supposed to write the request. For that, app.listen express.listen is going to listen to the port we are specifying. So for this, we are writing this function listen, and then we are specifying the port. So port is 5000. We have a variable called port, and we can have a callback function. So once this server is successfully started, it will run this function. So I'll just write a console log here. So here I'm just starting the server, and then using just printing that the server is started at this location, this port. So in general, in real-time applications, sometimes you're supposed to create a database connection objects, right? So that connection object will be created only once when you run the application. So such code can be placed in this part. So I'll start npm start. And then if I go to Postman, and if I run this endpoint, now here I'm using localhost 5000, and the endpoint is API/nodes. So when I try to hit this endpoint, it's going to send me JSON response of entire nodes. So if I send, as you can see, we got the response back from the server. Similarly, we can write different endpoints here. Now we'll write a response post request so that we'll add the data to the list. So first we are supposed to get the ID of the last node, right? That is same as in the previous example. So we are just declaring ID variable called last ID. Here we'll just check if nodes dot length equal to 0. If it is 0, then it is going to be the first node. Then ID should be 0. And if it is false, we are supposed to get the ID from the array, right? So nodes is the array. Here we are supposed to get the last index. So that is nodes dot length. So here, if initially we have only 5 nodes in the array, so the array length is going to be 5. So array index starts from 0, right? So we're supposed to take -1, and it's a JSON JavaScript object. So in order to access the ID, we're supposed to get object dot name of the parameter or variable. Because it's ID, we are using ID. So here we are going to get the last ID of the node. Once we get the last ID of the node, now we can create we will have the data in the response request object. So we'll create a node object. So this is the new node that we are adding to the array. So first we'll add the ID. This is the JavaScript object ID colon and the ID of the new node, which is going to be the last ID plus one, right? Last ID plus one. And now we are supposed to add the content. So the content, and this is the name of the object value, and then value is supposed to be something that we should get from the client, from the user. So that is stored in the request object. So request dot. So if you see body, because it's a post request, the entire request data, like form data, will be stored in the body, right? If it's a get request, it is going to be stored in the URL. So because it's going to be stored in the body, we will use request.body dot name of the HTML element. So here we are using name as content. So we'll use request.body.content. This will get the content text from the content. And again, we are supposed to specify if it's important or not. Again, important. And here we'll just check if request dot body dot important. Because here, if you see in the HTML, the checkbox has a value called important, and the value is going to be on. If it is selected, then it's going to be on. If it's not, it's going to be off. So we have to store it in a Boolean format, right? If you see here, importance is either true or false. So here we'll check a condition. If it's equal to on, then it's going to be stored as true. If it's off, if it's not on, then it will be false. And now we created the note object. Now what we're supposed to do is add this note object to the array so that we can use notes dot push. So this is going to append the new node to the end of the array. And then you can send the response to the user. We'll set the status code 200. We'll send back the note. So as soon as I save the code, the server get restarted and we can do the post request and check it. We'll write the delete endpoints also, and then we'll check the application once. So for deleting, we are getting the for delete, we are using a method called delete. So in the even for the delete, we need to use request.params because the ID is going to be stored in the URL. Because it's going to be stored in the URL, we are supposed to use params because it's parameter. So we'll get the ID, note ID. It's going to be stored in the parameter, which is request.params.id, because we are passing the ID of the deleting node in the URL, ID equal to ID of the node. So the params.id is going to give us that value. Now we'll just iterate over the nodes and delete the node which is with the specified ID. We'll use nodes.filter, and this one takes a function. So here we'll take each node and check if nodes node.id not equal to node ID. We are just disabling the cache because every time, suppose we delete every note in the application, and when we start adding the note again, the ID is going to be one, starts from one, right? So because we already deleted the node, the browser is going to cache the URL and it directly starts redirecting us to the home page instead of making a backend call. So we are just disabling the cache to avoid that. And then we'll just send back the JSON data of the nodes. And we'll also set the status code 204. 204 is for when it's generally used when we successfully delete something using the delete method. So if we go to this endpoint and if we check, we are getting all 5 nodes. So we'll try to delete a node, api.delete. We're trying to delete the second node. So we got the response as 204, which is successfully processed. So if we again try to ping the get endpoint and see, so the second one is missing, right? The second node is not there. That means we successfully deleted it from the server. So we'll again delete the first node. And this is also deleted successfully. So like this, we can test the backend separately. And for this application, I already wrote the front end. So now the backend is not there. We are supposed to use JavaScript and get the data from the backend, right? So there are generally two ways to do that. So one of them is XML HTTP request. This is very old, but it still works. And this is the sample code here. We can make the backend request from the front end. So this is the way we create the object XML HTTP request. We are creating the object, and on ready state change is the event handler here. So as soon as the state of the for every endpoint, we are sending a status code, right? From the backend. For delete, we are sending 204. For a successful get, we are sending 200. So once the status code is changed, this function will run. So whenever the status code of a request is changed, it means that the request has reached the server and server processed it and changed the code, right? So this method will be triggered. So and this method will also have the data which is required, which we get from the server, and we can render the data in the front end. So this is XML HTTP request, and it has like as soon as first you have to write the callback function and check the status. If the status is success, then we'll process the data which we got from backend. And then this is a callback function. And then we will open the request. In the open method, we are going to specify what type of request we are making. If it's post request or get request, and then file name or the location of the URL. For these endpoints, we are using /API/nodes and then delete. So like that. And then HTTP send is going to send the request to the server. This is one method. And I wrote HTML code already. So this is the very old method of getting the data, and it's a little bit complex than the fetch. So there's another thing called fetch. So fetch is very easy and easy to write. So generally you can write XML HTTP even without hosting the front end somewhere. But with fetch, you are supposed to deploy the front end application also somewhere. Then you are supposed to get the data. So this is the front end code for that. So we're just opening the XML HTTP request. And then here in the HTML itself, we have a URL, base URL defined in the code itself as a variable. Here I'm just using base URL /nodes, which is opening a GET request to the nodes. And then onload function, once the status is changed, will run this method. So this method, if the status is 200, it means that we got the data back from the server. So the data is stored in this XHR response text. This is the data we got back from the server. So because the data we are getting from the server is JSON. The format is JSON. So we are passing the data using JSON.parse. Now this will convert the entire thing into a JavaScript object. So now we are creating a list node and then appending the list node to the nodes list. So the nodes list is here. Document.getElementById nodes. So this is this part. So it will get this element, and then we are adding the new list node each time to this nodes list. So if we get any error while fetching the data from backend, that means the status code is other than 200. So that case we are handling in else part, and then fail to fetch where we can log the details or show any error pages if required. And then we are wrote another callback function called onError. So this will run when we have any error while sending the request to the backend. So console.error, we're just logging it. And once we write every code to process the callback after success or process the callback after failure, we'll just send the data to the backend. Similarly, we have the same code to add the request. So as soon as you add the request, we are supposed to send the data to the backend, right? So that for that, we are just creating a form data. So I added a event handler for the submit button. This is this part. So as soon as we click on that button, it will trigger this event and we will run this function. So here we are again opening the XML HTTP request, and then we are sending a post request this time. Whenever we are sending a post request, we are supposed to send some data to the backend. So now if you see here, we change the content type to JSON because the backend is only accepting the JSON type. Because we set it that way, and we change the content type. And now we are appending. We wrote the callback function. Once you get the data once you successfully send the data to client, it's going to process the data, and again it is sending us back the new node, right? So that new node, we are supposed to add it in the HTML file because we are supposed to display it. So again, we are creating a new li node and then appending it to the node list. This node list is the UL tag. In backend, yeah, in memory. We're just storing it in array. Suppose, yeah, real database, you can use a database like MongoDB or something. And so there's something called .env. So that is environment file. So in that file, you can specify the credentials of any application. So that file is only accessible by this application and nothing else. So you can store the username, password there. And whenever you are trying to run the application, there's one more external library called .env. So you can use that env and get the runtime environment variables from the process itself. It's so that is also easy. Uh, I shared some additional resources in the slides, so you can go through those slides, and it has everything that's related to database also. So we'll send the now we are sending the new node to the server xhr.send. So once we get the response back, we're just appending the data here. So now if you see, the backend code is different and the front end code is different. So I just placed it here, but you can take this file and place it anywhere and can run it. I'll just remove it from here and place it on desktop. So I placed it on the desktop. Now, if I open the file, so it's failing because of cross origin or request. It's not able to make the request to the backend because we started the server here with 5,000, but the URL we're trying to access here is 3,000. That's why. So if you see here, we got the details from the server, and we can delete the nodes. We can do same operations as before. So this is, if you see here, the front end is separated and the back end is separated. Now I'm able to write the back end without thinking about the front end. I wrote the entire endpoints without, if you see the backend code here, there is not a single HTML tags written, right? So this is easy to maintain and you can easily test. And the amount of code in the backend is also pretty small compared to the normal Node.js one. And there is one more called fetch. So fetch is even simpler than XML HTTP. So, but in order to use fetch, you're supposed to use any libraries like React or Angular. So I just wrote a Angular React application as well, just to show the demo of fetch. So this is a sample React application. So those you have attended the front end workshop, you know like what React.js is. So React.js is basically a front end framework, and you can use it to create front end applications which are modular and easy to maintain. So the problem with normal HTML files is you can't test them, and you can't test, and it's hard to maintain. So and suppose if you take a website, the menu bar is included in every HTML page. So if you write normal HTML without using any libraries, you're supposed to write that HTML menu tag in every HTML page. It's redundant code, right? So like that, there will be so much redundant code that you have to write in every file. So if you use a framework like React, you can wrap this redundant code in components. You can use components and then reuse the same component in multiple places. So that the amount of redundant code is less and the maintainability of the application and testability is also pretty easy compared to the normal HTML files. So this is the fetch part in the React application. If you see, I'm just using one function call, which is fetch, and then I'm specifying the endpoint of the backend, and then I'm specifying the method. And this will call the backend, and we are just checking the response if it's okay. Response.ok is same as the XHR. We are just checking if the response is successful or not. If it's successful, it means that we got the data from backend and we are just adding it to the list here. So this is the fetch API. And now if this is how like generally people write code in real time applications. So backend is separated, front end is separated. So if I want to run this React application, same as this is also npm application, right? So it also has a JSON package. So if you see here, we have a bunch of dependencies, these dependencies. So in order to run the application, we need to install these dependencies, which is npm install. Once we install all the dependencies, we can just run npm start, and this application will start on the different port. Previously, with XML HTTP, we are not required to write any. We are not required to host this anywhere. We just ran it in the React like normally opened. If you see the URL here, this is not HTTP. This is just a normal file that I opened. So this XML HTTP can run anywhere. It does. We don't have to host the website, but it also has a lot of security issues. So that's why generally people don't use this. They use front-end libraries like React or Angular and then use the fetch API. So that is the separation of front end and back end applications. And these are some additional resources that if you want to learn about backend or full stack development, this resource, I use these resources a lot. So this is, I would recommend using this resource. It's full stack open IO. So this site is amazing. Like you'll find all the courses, not just for backend, but also front end, backend, and then it will use different like some of the popular frameworks like Redux, and then it will also uses the MongoDB for database. So you can see all the parts. This is open source and it's free. You can use it without paying anything. Huh? Yeah, it's just like a tutorial. Like you'll find all the information about backend and front end development. Yeah. For that, there is one more resource. Um, so if you are new to JavaScript, I would suggest before starting web development, I would suggest you to go through this site. So this has all the syntax and all the basics required to basics for the JavaScript. So it starts from very basics. and you'll understand everything like asynchronous calls and everything which are required for developing web applications. So if you start with this, and if you after completing this reading material, and if you start this course, you'll easily understand like what React is and what Node.js is. You'll understand everything from basic. And if you want to, there's one more site called Odin project. So this is also same as Open Full Stack. So this one is more like project-based development. So it's easier if you want to run the application or build the application, you can use this site. So they have full stack using different languages. And if you are interested in taking any video courses, would suggest taking this course. And then there's one more free coding campaign. Many of you would know that. So there's a course on with them also. So you can take that. And if you want to take any courses in Northeastern itself, you can take this course Info 6150. So I already took this course last semester, and you'll get to know about it. Will start from basics from in HTML, CSS, and then they'll teach us JavaScript, and then you'll slowly start using different libraries like React, Angular, and Node.js, and then MongoDB. And if you want to just focus on the backend development instead of full stack, there's one more course called Enterprise Software Design and Web Tools, Web Methods and Tools. So this one is backend development based on Java and Java Spring. So this is about the backend development. So I hope everyone like understood what backend development is. So obviously this workshop is not going to teach you everything from basic. At least you got the idea where you can start and what you need to know to completely learn the full stack of backend development. Yeah, I'll share. Yeah. So if you have any questions, you can ask me. Yeah. Okay. Yeah, I know. Yeah, I also have like 2 years of work experience in Java Spring, and Java is very difficult to understand even. It's very complex. Yeah, yeah, it's very easy. Yes. And because if you learn Java Spring, you need to know front end. Like if you are going to full stack development, you need to know backend and front end languages, right? So if you are going with Java, you need to know language frameworks like Java, Java Spring, and then you need to know front end libraries like React, Angular, those things. So if you like choose Node.js or JavaScript, then it's just easy. One language, you can use it for front end and you can use it for back end also. So the basics is going to be the same. Yeah. I can paste this links if you want in the chat. Yeah, I'll ask Jenny to send it. If anyone has any doubts on Zoom, you can ask me. Uh, okay. If not, we can. Yeah, thank you. No problem.